Hello everyone. This lecture is about machine health monitoring and its equipments. We'll see how machine condition monitoring is done and what are the various instruments, techniques and methods we are using in industries to check the condition of machines. There are two pictures right now on the screen. Below picture is the set of machine and the above pictures are having plots and diagram, graphs, some data. So whatever machine or system machine we are using, we can get the input and output in terms of these graphics. And by clearly observing these input and output, we can get idea about our machine, whether it is working right or not. Another diagram gives you idea about a system where we have input and output from a machine, including gear, sensor, and amplification. Important here is that you can easily observe the pattern of input and output, and you can easily get an idea about whether machine is working well or not. So accordingly, you can take some preventive actions to avoid any failure. A few more examples, you can see the devices we are using to get the output in terms of plots. So device we use with the system, then system gives you output in terms of plots. So if your output is within the given limit, you may say that machine is working well. And if the value goes beyond the permissible limit, you should always check, like the diagram below diagram shows you that at few points the values are going uh, above the permissible limit. So you should always check at those points. You should always check the settings. You should always check the part which we are using to avoid a failure of this kind of system. Now, this kind of condition monitoring technology for machine and equipment, you can connect with our health monitoring process. Like a person who is not feeling well goes to hospital, then hospital go for certain tests like ECG, blood sugar, blood pressure, and some joint joint. They can get X-rays and other devices they can use to get the condition of your health. Similarly, you can use various devices, various tests to check the condition of the machine. So this is how you can relate this machine condition monitoring to your health monitoring process. So in this lecture, we have a topic like equipment failure. We'll talk about condition monitoring, preventive maintenance. Then there are certain methods and equipment based on temperature, corrosion, non-destructive testing. So we discuss on this, and this lecture will give you brief idea about the concept, the methodology, the importance of this predictive maintenance. Let us begin with the standard definition of condition monitoring. These are the tasks which are scheduled activities used to monitor machine conditions and to detect a potential failure in advance so that action can be taken to prevent that failure. So you should always get idea before actual failure takes place so that you can save your machine, you can you can reduce the breakdown time, you can reduce your cost. So here, if you are using some condition monitoring equipment, they should be always applicable to the machinery which we are using. They should be effective. Then it should always detect the failure. It should have some framework for network-based data collection. So these are the various important aspects of various condition monitoring devices. Then there are certain standard definition which are important as far as condition monitoring process is concerned. There are certain baseline data which are the basic data by which we compare the actual data. Then every part is known as component. Then we go for condition based maintenance. That means you prepare a maintenance plan on frequent basis. Then there is a condition monitoring. This is the scheduled diagnostic technology used to monitor the machine condition. Then we have data historian. Then we can detect the failure mode by going through these data. You can predict, you can observe, you can analyze the failure characteristic, means how manner this failure takes place. Then you should always eager to know the failure effects. Then you should design the failure management strategy, failure mechanism. You can detect failure rate. You should always predict for any part or machine. Then you should always see how this frequency you can control of failure. Then a function which is a system, equipment, items, or components which we design for our machine. So these are the certain standard definition for various terminologies, various concepts which are useful for machine condition monitoring. So you should always be aware about the potential failure and preventive maintenance. It consists of all the maintenance tasks identify as necessary to provide an acceptable probability of survival to the end of a specific interval. You should always be cautious about random failure because it is you cannot predict these random failure. Then you should always be ready with reactive maintenance. You should always be ready to react to the conditions you are facing. So this is how a person who is in charge of machine condition monitoring, who is the plant in charge, who is the maintenance in charge, he or she should be always comfortable. You should always be aware about these kind of concept, this kind of data which are going to be helpful in checking the machine health. Then why equipment fails? So equipment may fail due to several reasons which are shown on the screen right now. There may be some design error due to faulty material, improper fabrication may be the reason, improper installation operation, and there may be some inadequate maintenance also. So there are several reasons for any equipment to fail. So any plant manager, any engineer, any maintenance engineer should always be aware about the possible reasons of failure so that he or she can take preventive measurements. He or she can plan for maintenance of the machine. Now there are few pictures on the screen right now where a machine or part fails due to certain reasons. So as engineer, as a engineering student, one should always be eager to know the reason behind these failures. So the reason you can find in different subjects in your engineering course. So whatever subjects you study in engineering course, whether it is material science, mechanics of solids, theory of machines, machine design, thermodynamics, heat and mass transfer. So all these subjects gives you idea about how material behave, how a component can be designed, how a machine works. So all this knowledge will help you to detect the reason of this failure so that you can improve the design, you can improve the process. So these machines you can save by failure. Important here is the failure rate. It is expressed in terms of operating time before an item of equipment fails. So the time a equipment spends is its life cycle, and it is also a failure rate, means in terms of certain time period you can show the failure rate of any equipment. And it depends on variety of distributions. So you get failure rate in various distribution like normal distribution, exponential, log normal. So we'll see in detail about these failure rates. Now failure patterns, every equipment fails and you can see the pattern of that failure, and the common pattern of failures and the common characteristics are three. You can see on the screen: wear in failure, another is random failure, and next is wear out failure. So wear in failure is due to the weak members, due to the manufacturing defects or improper installation, maintenance, and startup. So these kind of equipments fail in the beginning of the process. Once you start the machine, those parts get broken or get damaged. So this kind of failure where the part fails in the beginning of its operation is known as wear in failure. Second one is the random failure. You cannot detect, you cannot predict the time when this random failure takes place. It can be due to extreme conditions or human errors or sudden stresses beyond the permissible limits. So you cannot predict this random failure. You should be always be ready for this. Next one is very common, the third one, and you all know that wear out failure is dominated by the end of useful life issues for equipments. So once we complete this useful life of any equipment, it fails due to its completion of this life cycle. and you get this kind of failure is very common for most of the cases. There are six failure rate patterns, and a person, an engineer dealing with this failure of machine should be well aware about these patterns. So you can see on the screen right now, one is the bathtub, second one is the traditional wear out, third one is the gradual rise. So I'll discuss few of it, and you can see with this second pattern, we'll try to understand the pattern B, that is traditional wear out, where you can see the slowly increasing failure rate is there, followed by a wear out. So this is the standard, you can say very common failure pattern we find in almost all equipment, that it works for a particular life period and then it fails at a very increasing rate, and once it completes its life cycle it fails. So this is the common pattern we get for failure, known as traditional wear out. Example is reciprocating engine and pump impeller. Likewise, I'll take the last pattern, that is pattern F, infant mortality. Here you can see high infant mortality is followed by constant and slowly rising failure rate. Examples are electronic components. So you all know that if a electronic component is properly manufactured, it is, if it is properly fitted to any assembly, any instrument, it will work properly. But if it is not properly fitted, it suddenly will damage, or it will not work. It may fail in the beginning itself. So this kind of component which fails in the beginning is under the category of this failure, infant mortality. So the chances of failure is in the beginning, and if it is works well, if it works well, then it will work well throughout the life cycle. So this kind of different patterns you have for different components. So we all should be aware about the pattern of failure to predict the failure of any equipment or machine. So in summary, we can summarize that the common equipment life periods are three. One is infant mortality, second is useful life, third one is the wear out. So wear out is when you complete your life cycle and machine fails due to the wear. Useful life we get, it is longer than the other two periods, and infant mortality is the case where the equipment fails in the beginning of the operation. So this is the common a life period plot and life period rate we can estimate for most of the components. Then predictive maintenance we should always be aware about, and it is very important to check the failure of the machine. So here important here is the potential failure PF diagram. You can see in the diagram that there are 2 points. Point P, where we can detect the onset of the failure, means we can see the beginning of the failure, while point F is the functional failure, complete failure. But important here is that you should always predict the failure or the possibility of failure well before this point P. So there is a point where failure begins. So if you if you can predict, if you can observe that failure may take place in any machine and part well before the actual failure takes place, then you will be able to save the machine, you will be able to save the cost and time of the company. So this PF diagram helps you to get you the point of failures, and you should always be ready to go for preventive maintenance to save this failure. Then comes the various condition monitoring techniques. Right now on the screen you can see these techniques are based on temperature, oil analysis, corrosion monitoring, non-destructive testing, we have electrical testing. So like once we go for body checkup, there are several tests, several methods. So likewise for machine health, for machine condition monitoring, we have various kind of measurement and techniques. We also we will see this one by one. But the common thing is that these techniques and tools must be applicable to majority of the machines, and they must be effective. Means onset of failure should be detectable. You should always a tool and tool we are using should always detect the failure well before the actual failure takes place, and we should get the proper PF interval so that we can take preventive maintenance step. Then you should get sufficient warning so that corrective actions can be implemented, and important here is it should be cost effective. So these are the various uh, characteristics any tool should have. Let us see all these techniques one by one. We'll start with temperature measurement. There are two techniques. One is the point temperature, where you can take temperature at certain points, and another is the infrared thermography. But why this is important, that you can see, suppose you have a failure due to the excessive friction in case of faulty bearings or inadequate lubrications. So in that cases, if friction beyond certain limit, the temperature will rise, and due to this, using this tool, you can detect the temperature rise, and you can find the problem, and then you can take preventive steps to stop the machine, to save your machine. You can change the bearings, you can change the lubricant, and accordingly you can control the temperature. Similarly, if there is a problem in the heat exchanger, then you can check by the temperature, and you can change the settings of heat exchanger, or you can change any part. Similarly, in electrical connections, if there is a over heating, then you can check the temperature and change the part or change the setting of the part. So these are the very important tools to check the temperature, and you can take corrective actions according to the readings you get in these tools. Two examples for infrared thermography you can see, one is for electrical motor bearing and another one is the belt slipping. In both cases, they are moving at very high speed. You cannot take temperature at a point. So we use infrared thermography, where you can see that you get by thermography you get the picture, and you can find the region with high temperature. And if you suppose these temperature goes beyond your permissible limit, you can check with this machine, you can change the part or you can change the setting of the part. So this is how we can control, how we can check the temperature at particular point of a machine. Then comes the dynamic monitoring. It is very common for rotating machines to check the vibration. You can see on the screen by the time the value of displacement acceleration changes with the time. And if it is standard, means if this kind of pattern is acceptable, if this is standard pattern we get for any machine, then it is okay. But if at certain points these values goes high beyond the permissible limit or goes down to the lower side of the permissible limit, you should always check the machine. So if we get continuous output like this, if we get continuous data like this, we can easily predict the performance of machine. We can check the part of machine if we get any variation in this kind of plot. So this is why this dynamic monitoring is important. There are a few dynamic monitoring techniques. We'll discuss two of this. One is the time waveform analysis. You can see on the screen right now. You can see in this in the diagram that at various points you can get the vibration, and due to the different parts, the vibration pattern will be different. But you can get the overall vibration diagram for the machine, like one is given in this picture. So overall vibration diagram you can check, and you can check whether it is within the given permissible limits. And if it goes beyond the permissible limit, you should always check the machine, and you can save the machine before it fails. Second method is shock pulse method. You can see by the picture, we are using a bearing, and you can check the shock which it gets due to operation. And if the shocks we are getting, the vibration we are getting is within the given permissible limit, we may say that machine is working well. But if these values goes beyond the permissible limit or very unexpectedly, then you should always be ready to check the setting of the part. So this is how dynamic monitoring techniques works. Next is the oil analysis, and it is based on regular scheduling sampling, and it allows monitoring of the rate of the change of the parameter. The important aspects of oil in many cases where these oils is used in petrochemical industries, what they check for lubricant condition, they check for contaminants, they check for machine wear. So if you are using lubricants, and if you use lubricant for a long time, you always check the condition of that lubricant. You should check whether it has some contaminants or not. and due to the wear, there may be some chance of mixing some foreign elements in this. So you should always check the quality of oil we are using for lubrication. So there are certain techniques we use for, we will discuss few of it. There are a number of techniques available to condition monitoring based on oil analysis. One is atomic emission spectroscopy, which you can see in this picture right now. We use a hollow cathode lamp, and that light passes through the fluid, and in monochromometer you get the diagram, and by the output you can see the quality of lubricant. Similarly, you can check the moisture of any lubricant, any oil by device like shown in the diagram right now, to check whether the moisture is within the given permission limit or not. Similarly, you can check viscosity of the lubricant by this kind of portable instrument. So there are several equipments available for oil analysis condition monitoring techniques, and a plant manager, production manager, a maintenance manager should be well aware about these instruments and using these techniques. Next comes the corrosion monitoring. The corrosion monitoring is important where we use in large industrial plants, and it helps us by providing early warning that a damaging condition exists. So we can save our machine, we can stop the machine, and we can check about the part. So it determines the root causes of a particular corrosion problem and identify the rate controlling parameters such as pressure, temperature, pH, and flow rate. So these kind of parameter we can check continuously, and if these parameters are in control, whether pressure, temperature, pH, and flow rate are controlled, we can be sure that machine is working well or plant is working well. And if these parameter goes beyond a certain limit, you should always be ready to check the machine. So it provides the operator and shore side management information also relating to the maintenance requirement. So this kind of monitoring we can use to give instructions to the maintenance staff. So these are the common technique used. By the picture you can see that the devices are used for large constructions as shown in figure, and we continuously get data on pressure, temperature, pH, and flow rate. And if those data varies unexpectedly, we can get idea that corrosion may take place, and before this plant completely fails, we can stop working and we can start repairing this. Then there are certain non-destructive testing techniques also. They involve X-ray, ultrasonic testing, and these are the non-invasive to the test subject. We need not to touch the object. Many of these tests can be performed while the equipment is online, and they can be conducted on the structural stationary component as well as rotatory components. We can see for flow problems, for flow of fluid which is mm, uh, down the ground, which is well below the ground, under the underground, the flow you can check by these devices, which is very common. So you can check any variation in the flow using these devices, and you can do the preventive actions. So there are a number of non-destructive testing techniques which has their own limitations, applications, and effectiveness. So one should be always be ready to get complete idea and the technology, the limitation of these devices. Last one is the electrical testing, and electrical testing is very important because it measures the changes in system property such as resistance, conductivity, strength, and potential. So if you check a system, if you check a electrical panel, if you check a electrical complete network, and you check the values of resistance, conductivity, and potential, so you can check whether all the properties are within the control or not. So these techniques help us to detect the electrical insulation deterioration. It may detect the broken motor, rotor bars, and a shorted motors, stator lamination. We can save our machine by short circuit. So you should always continuously get data on the performance of electrical system. And if you find some data which is unexpected, which is not common, and they are varying unexpectedly, then you should always be ready to check the machine. You should always ready to save your machine before failure. So again, there are many electrical testing and monitoring techniques. Each has its own application and limitations. So those who are in this field, they should go in detail with these techniques. They can get more idea about these techniques in several literature videos available on the net. This was all about this lecture, and I hope this lecture gives you an idea about the machine condition monitoring and the techniques, and the details is always advisable that you go from standard textbooks and research paper to get more on this. Thanks.